just want to thank you for being here tonight. This is me. This is what I look like. I have a face for radio, they say. But again, thank you. I really appreciate you being here. So, what is a community health needs assessment? At its very core, is it is an assessment of what is going on in the community in different ways to understand what are the health needs, what needs to be improved, what needs to be addressed, etc. And there's many different ways of doing these community health needs assessments. A lot of surveys may go out to the community. A lot of community health workers might go home to home. Uh, some of the counties or some of the localities might not have enough money, and what they do is that they get data from other sources, and we're going to kind of emulate that tonight in our project here. I'm going to be walking you step by step in each thing that we need to do. So this is going to be a little bit of a lengthy code along because we're going to set up R, and we're gonna get to this environment that you see behind me, and then we're gonna get going with getting the data, and then we're gonna analyze the data. I have already written the script, but you'll see me trying to do it again from memory. I might refer back to what I've already written, but I'm gonna try to do it as much as I can off of memory. One thing that I do recommend, if you have the ability to get it, is Copilot from GitHub. So GitHub is a repository of data and code for a lot of different projects that a lot of different people around the world use, and a lot of software in there as well. And they recently released Copilot, and you pay about $10 per month for it. But if you're doing a lot of coding, it's really worth it. You'll see it, and when I'm writing, it tries to autocomplete what I'm writing. I try to go with what it tells me, but I also want to verify it, right? In this age of AI, we're barely starting. We're barely starting with AI. It's a wonderful tool, but we need to kind of understand everything that's going on with it. So if you see me look this way, I'm looking at my main screen. If you see me looking this way, I'm looking at the R Studio. I'm gonna hide my face for most of this. If you see me looking down, I'm looking for your chat comments. And if you have any questions along the way, just make sure to subscribe so you can leave a comment, and then we can get going. So with that said, I'm going to go ahead and bring up the on this screen. So let me hide myself just a little bit. So I'm going to bring up the Baltimore Neighborhood Indicators Alliance. I want to give a big shout out to the Baltimore Neighborhood Indicators Alliance. They have done really good work in Baltimore for many years in collecting data from all sorts of different sources, the census, the city, hospitals, healthcare systems, etc. And they release a yearly report called Vital Signs. And this yearly report really tells us what is going on in Baltimore. It's been very informative for a lot of people working in public health, so we know what is going on in the city of Baltimore. For a lot of people who work in the city government, they can use this information and to do all sorts of interventions on the public health level, safety level, economics, etc. So let's look around the Baltimore Neighborhood Indicators Alliance website here. Let me make it a little bit bigger so you guys can see it better. And so if you can just look at the report, you can just click on this and look at the report. And this is a full report, neighborhood by neighborhood, community statistical area by community statistical area. And so a community statistical area that BNA uses is a grouping of neighborhoods. They're grouped by their history, their demographics, their traditions into community statistical areas, 55 or so of those. And then they do the data analysis. So this is where we're going to get a lot of our data from. There are other sources of data around the country. I'm going to share a couple of them here with you. So this is the main data from the Baltimore Neighborhood Indicators Alliance. This is where we're going to be getting our data from in a little bit. We're going to also look at the city of Baltimore. The city of Baltimore, like many other cities, has their own open data portal. And here it is, as you can see. You can scroll up and down and look at the data portal. Chicago has their own data portal as well. So let me show you that real quick. And I actually did this analysis for Chicago, and I'll share it in the Epi Night School website later on. But you can see you can get a lot of data from different categories. So you can get, let's click on education. progress report cards from the public schools from 2011 to 2012. So a little bit of historical data right there, right? Libraries, locations, public schools, etc. So a lot of cities have a lot of these: Philadelphia, Houston, New York, Austin, etc. Another thing that I want you guys to pay attention to, and in your free time, take a read about the black butterfly and the white L in Baltimore. And this is something that you'll see that because of redlining back in the 1930s, 1920s, 30s, 40s in Baltimore and many other cities around the country, a lot of neighborhoods, primarily black and other minority neighborhoods, were left out of the ability to borrow money to have their own homes. So people couldn't buy their own homes. And that was the case in Baltimore. And you'll see the history of that still 100 years or so later. It is still impacting. If you're a homeowner, then you know how important that is towards your personal wealth. It's you're investing in that house. If you're a renter, you're not investing. You're spending the money just to live, right? And many people live day to day, so that is difficult to do. So let's see here. I'm going to go ahead and show you where we start by installing R. So we go to RStudio, download RStudio. That products sorry, Posit.com. They changed their name, Posit.com, and you go to, or you Google RStudio download for at Posit Studio Desktop, and you install R first, and you go to this website, and you, based on whatever computer system you have, that is the one that you are going to be using. So I'm using R for Mac, and I am using the latest release for the Macs with the M chips, but they also have for the older Intel Macs. So I would click on this, I would go through the steps and install it. If I were doing that again, I've already done it. You might want to do that before we get started. And then step number 2 is to install RStudio, and you do it. It will auto detect what kind of system you have, and you just download it, and you'll see. Um, it'll detect what system you have, and you download it, or you can download a previous version, but I recommend that you download the latest. And then you fire it up, and you fire up RStudio, and this is what it looks like. It has 4 panels to it. I will walk you through each of the panels. So on the left hand side here is the script. So this is the script where you will be writing your R script, and this is the script that you then can run. It R works very much like a calculator. So you see, you write result and 3 plus 4, and you either hold Command Enter or you click on Run up here, and now you see the result is 7. You can also print the result as I'm being suggested here, and you run that, and the result prints in the console below. And the console is where you will see the input that you gave R, and you'll see some output here. You'll also see errors, warnings, etc. So this is the lower left panel. Um, so the lower left panel, as you can see, is the console. The lower right panel is for plots, files, packages, help, viewer, and presentation. A lot of different tabs here. If you have questions about a topic, you can go to help, and you can find the different topics. So if I want to do, for example, logistic regression, or this is let's just say mean. So if I'm looking for the mean, I can have different types of code. I can have different things. So what I'm looking is for the arithmetic mean, and so it tells you what it's used, etc. So it's a really good resource. We're gonna leave it at plots for today. We're not gonna mess too much with that. And then at the top right is the environment. So the environment is telling you your values, like the one that I just quoted for 7, 3 plus 4 is 7. It's gonna allow you to connect to databases. It's gonna allow you to import data sets. A lot of really neat things that are kind of outside the scope of what we're doing tonight. But if you've got questions, I'm more than happy to address them later on. And you can also find a lot of help online for RStudio and for R in general. A lot of help. A lot of people have gone through a lot of issues, and they look for answers, and so they've been able to find them. So what I'm going to do is I'm going to delete all this script. So community needs assessment. Going back to that real quick, the data. I want data from different domains, and in the description of this video, you'll see a paper by one of my mentors, Dr. Castillo Salgado at Hopkins, and the paper talks about how you get data, um, geographic data on different domains. So we're going to do socioeconomics, we're going to do demographics, we're going to do mortality and morbidity and mortality, access to healthcare, and others. And what I have chosen to get tonight is the data that I'm going to be using tonight. I have chosen again, first time doing this, so you know that's how it goes. So I'm gonna be using I'm gonna be cheating here and going to my previous script. So I'm gonna get a map of the city. I'm gonna use a racial diversity index. I'm gonna use the level of blood lead levels in children, the gun number of gun-related homicides per 100,000 residents, the median household income, and the infant mortality. So that's what I'm going to be getting from that BNIA website, and then bringing it over. So let's go to that website and start building this community needs assessment and see how we can put it together. So one of the first things I'm going to do is I'm going to go to Files, and I'm going to just create a quick folder, and I'm just going to call it Baltimore for now. And this is where I will have all my files as I download them. I'm also going to go to Session in our studio, and I'm going to click on at the very top Session, and set the working directory to the files pane location. So what this does, if you see it there in the console, I'm going to show you. It is telling me that I have set the working directory as library, cloud storage, Dropbox, Epi Veritas, ANC, which is my business folder, Rene Nájera, and then Baltimore. So everything is going to be in this folder right here, and when I refer to something in the code, it's going to be looking for those files in that folder, and that's where I want to save everything. So if you are following along, go ahead and create a folder for yourselves where you will be saving all the files as we go along, including the script. So going back to the script, I'm going to click on Save As, and I'm going to save it as Baltimore Needs Assessment. And it's going to be appearing now in my files. There it is now in the bottom right. So now you see on the bottom right, we have the Baltimore Needs Assessment. It's this script that I am creating. Okay. A neat thing that you can do here is delete. It's clear your console with the little broom right there, and clear your environment with this little broom up here, and make sure that you're starting clean. So let's go get the data. Let's go to the Baltimore Neighborhood Indicators Alliance and the vital signs. So I'm going to look for the boundaries first. I'm going to look first for the boundary file for Baltimore City. And these are the community statistical areas reference boundaries. And so we're going to click on that. And it populates it for you. It shows you the map. It shows you the different community statistical areas, which, as I said earlier, are the neighborhoods put together in Baltimore City. So here they are. And then you can click on them and see them if you want. But what we're going to do is we're going to download, and we're going to download the shape files. Now, what this will do when you download it is that it's going to download it and ask you where to save it. Again, I'm going to save it in Baltimore, and it's going to save it as a zip file. This is fine. You don't need to unzip it. You don't need to do anything with that. We will use R to unzip it and extract the information. So that is number one. Number two, we are going to go and download now the racial diversity index. So what the racial diversity index is, and it gives you the summary here, it is a percent chance that two people picked at random within an area will be of a different race or ethnicity. So it tells you how diverse the city is. And so we click on this to open the community statistical area. And if you look at the different, for example, this community statistical area, Forest Park, Walbrook, has a racial diversity index in 2019, which is the latest one, or 2022, which is the latest one, of 32. So over time, you can see from in 2010, it went from 10.7% chance of seeing somebody of a different race or ethnicity to 32.8. So it is getting more and more diverse. You see this other one up here, Pimlico Arlington Hilltop, which is where the racetrack is. It went from 12 down to 8, up to 10, 13, and then the more recent one is 20. So also getting more diverse. There are other community statistical areas that are not getting any more diverse. They pretty much hit the peak. And so again, this is just another one that we're going to download. We're going to click on shapefile just like we did before. We're going to save it along in our Baltimore folder. Now we're gonna go for the lead levels. So the percentage of lead, percentage of children aged 0 to 6 with elevated blood lead levels. And so you'll see that this one doesn't have a lot of information because, well, it seems like it doesn't have a lot of information, but it's actually because not a lot of children have lead except for certain areas in the city. And I'll show you what that looks like when we actually do the analysis. So again, saving the shapefile for that, and we're gonna save it here. Now we need a measure of mortality. So we're gonna go and look at the, we're going to look at years of potential life lost, or morbidity, mortality. Let me cheat real quick. I'm gonna cheat real quick and go back to my notes, and homicides. Homicides is what we're gonna use. So homicides. Number of gun-related homicides per 1,000 residents. Baltimore City, if you know, the city has had a lot of issues with homicides in the last few years. Well, actually in the last couple of decades, but in the last few years, 2 or 3 years, the number of gun homicides per capita has actually gone down, thankfully. Something seems to be working. So we're going to be saving that as well. And then we're going to go for medium household income, so our measure of economics. And notice that these are all in different domains. We want that. We don't want to get a lot of variables from the same domain because we're just getting the same information over and over again. It's too much information. We want a variety of information from socioeconomics, demographics, morbidity, mortality, access to healthcare, etc. So again, medium household income, save the shapefile. I'm gonna save it there. And then the last one was infant mortality. So infant mortality rate. And this is different than gun homicides, right? Gun homicides tend to be adults. Infant mortality, newborn children, tells you two different stories of what is going on. And they're highly correlated, as I'll show you later on, which is kind of interesting. And I think that the confounder, or the thing that is influencing the two of them to make them look like they're correlated between them, is actually socioeconomics. So now we have infant mortality. Okay, so we have all our data that we're going to need, and we are going to go ahead and go back to our studio. So I am going to first, one of the things that you need to do is your necessary libraries. So for this library, we are going to use Tidyverse, which is a collection of different software packages into the Tidyverse major package. It helps us wrangle the data. So wrangle data. And you notice I put a hashtag or a pound sign before the comment, and that's just so that that R will not read this. It'll just ignore it. Anything to the right of the marker. Library SF for simple spatial data. This analyzes spatial data. So all of that data that we just downloaded is all spatial data. It has latitudes and longitudes of all those different polygons, all those different CSAs or polygons. Is the way that we're going to analyze it. We are going to use TMAP, which helps us create some thematic maps. This is what we're doing. We're going to create a thematic map of the index of unmet health needs in Baltimore. Let's see, what else do I need? RStudio API, no, G core plot is the other one that we're going to use. GG core plot. And so let me put this all on the big. Uh, Let me make it as big as possible for you guys so you can see it better. Okay. So it's to create GG core plot is to create a correlation plot, so we can look at the different variables and how correlated they are. Okay, so we have that, and now we're gonna load the data. Okay, the city shapefile, and this is we are going to. We don't want to do that. We want to actually get it from our. We want to get it from our files down at the bottom right. Um, the name of it is okay. st read. So this is coming from the SF package. As you can see, st read is coming from the SF package, and it tells you what it is. Read simple features or layers from file or database. So very helpful. RStudio already kind of pre-fills all of that for you and helps with that. So I'm looking at the chat, by the way, guys. If you have any questions, make sure to put them in the chat, and let me know if I'm going too fast or slow or just right. So we're gonna read not that, my dear R, not that. Don't pre-fill it for me. We are going to read the file. Community statistical areas boundaries .zip. And so before we do anything else, I'm going to show you how it reads this. So let's go ahead and show you the whole screen, and the data on the bottom right is that's where my data came from. So I'm going to load tidyverse. I'm going to load SF. So remember, command return to run that line, or just click the run button to run that line. And then I'm going to load the city. All right, so here's one problem. Read community statistical areas boundaries zip. So one thing that might be going on here is that it doesn't like spaces, and those might need to be underscores. Nope, that is not it. Okay. So we might need to unzip it, which is fine, which is what I ended up doing last time. So there, now it has unzipped it. By just clicking on it, unzips it, and now they're here. So one of the things that you do is just community statistical areas boundaries / and you click on that, and this is the name of it. So you need to write that name in here. So we're gonna do community underscore statistical areas underscore parentheses CSAs parentheses underscore reference underscore boundaries shapefile. Community statistical areas boundaries. Community statistical areas. Oh, there's two spaces after CSAs. So see here at the bottom, there's two spaces there. So that's what's going on. And there, now it loaded the city. So very quickly now it has loaded the city. So let's go back to, and it's telling us a lot of information on the console about that shapefile. It is telling us that it loaded as city, as a name city, the community statistical areas boundaries shapefile .shp, and it comes with a lot of other files with it in the same folder. All those files need to be included, as you saw when I unzipped it. That's what it did. There is a way to do this with a zip file, but apparently I did not read the instructions very well earlier today, so I apologize for that. But this is good practice. This is good practice. We can all fail together on this. Anyway, it is a simple feature collection with 56 features, the CSAs, and 5 fields, so 5 variables. It is multi-polygon, so each community statistical area is a polygon. It is giving us X and Y dimensions, and it gives us the minimum and maximum of those X and Ys. Those are the latitudes and longitudes, and the projected coordinate reference system. So this is very important that you have different layers. It doesn't matter so much in a smaller map, so like a map of a neighborhood. The coordinate reference system can be a little bit off, but when you're doing bigger maps like states and countries, if the different layers do not have the same coordinate reference system, you might get into trouble, because there are different ways in which these things are being projected onto a you're projecting a sphere, right, onto a 2D plane, and so you need to adjust the coordinate reference system. So more on that later when you do the public health night school GIS later on in the fall. So now this is loaded, and I think this is a good time to take a very quick break and share something with you guys. I'm going to go real quick to my Substack, and so remember, phnightschool .substack.com is the place to go for the night school. Sign up and participate. And I am going to give you all a quick gift here as you're watching this. So give me 1 second. 1 second. I need to pull up a code for you guys. A special code, special offer for the first code along. So I am going to be putting it in the live chat in a second, but I'm going to be tricky about it, and I'm going to put it at the very top. So special code. Go to that March code along. So phnightschool.substack.com/March code along is your special code to get 1 month, 30 days free subscription to all the Public Health Night School posts that are lessons. Remember, the lessons are for the subscribers. The extras are free for everybody. So please go check it out. This code is good until April 4th. So for a couple of weeks, you get 30 days. You can access all the lessons that are behind the paywall. And if you'd like to stick around, that would be great. And if you want to give me some feedback on how the Public Health Night School is going, that would also be great. This is a labor of love. This is something that I'm doing to improve my own teaching skills, and to also spread public health to the masses, because we need a little more public health right now in the way that the world is going. So, anyways, back to the screen. So again, in the bottom left, you have your console. Now the city. I want to see what this looks like. So two ways that I can see what the city looks like. I can click on the city, and it will open in a tab. So community statistical area. Which neighborhoods make up that community statistical area? A link to the data for that area. The name for CSA 2020. So they change between 2010 and 2020. Not to worry too much about that. Just know that does happen as the neighborhoods change. They change the community statistical areas, and then the description of the polygon. Where does it belong? So a lot of data here from that city boundaries, but the best way to look at it is to actually make a quick thematic map of city. And there it appears at the bottom right. And so now you can see at the bottom right in the plots the city of Baltimore and its 56 community statistical areas are represented right there. So QTM, quick thematic map, it is part of the TMAP package. So if I were to go back to the script and say delete this, and then say TMAP, and then 2 colons, and then QTM, and it'll autocomplete for you when you have Copilot installed. Otherwise, you have to just learn the code. But you can see here it's giving you some idea of what you want to put in there. So that is how that works. So we know that the city has loaded. Now we need to do this with the other data. So to save us some time, I am going to go and just copy it from here. So again, 2010 community statistical areas, city map, ST read, community statistical areas 2010, community statistical areas 2010 shapefile. Actually, I should leave the city there, and let's do it this way. Okay. So we're going to call this city map, and we're going to get rid of these here because that's not the right shapefile that we just downloaded. Okay, so another tip for R is that if you do hashtag load data and then 4 dashes afterward, what it does is that here at the in this part, it'll kind of give you an outline of what you're working with. And so here we're working with load data, and you'll see as we do the other ones how that'll change. So city map is there. City map, the racial diversity index, and of course it's I need to go back to my files. So let me show you the whole screen again. And if you see something in the background, if you hear something in the background, it is my daughter that just got home. And okay, so racial diversity index, community statistical area. Click on it, gets unzipped. Community area boundaries, children blood lead levels. Click on it, and it gets unzipped. Gun-related homicides, and this is on Mac, by the way. I think Windows has the same functionality of unzipping zip files. I haven't worked with Windows in a while with that particular function. Okay, so racial diversity index and percent lead, homicides, income, and infant mortality. Okay, infant mortality gave me an error, so let's see, what am I doing wrong here? Infant mortality rate data. Okay, so infant mortality rate data, and there it is. So now I have all the data that I need to put together, and now we're going to do some quick data analysis. So let's do quick thematic maps of every single one. So you saw the city map. Let's look at homicides. What does that look like? And homicides, gun home is the variable. So I want to look at the latest data. So 2022, GUN HOM 2022. Okay, gun home 2022. So the shapefile goes in that format. Let me bring the script closer to you guys. The shapefile goes as homicides, and then which I named up here, and then which I named up here, and then the variable is GUN HOM 2022, which is the latest. So that's how that's gonna work. And sorry if you saw the screen move a little bit. I clicked on the wrong screen. So fit the screen. There we go. Okay. So that is the quick thematic map is this right here. So gun homicides, don't worry, we're gonna make it look pretty, but this is just a quick thematic map just so you can see your data, and you can see where most homicides per 1,000 people happened in what community statistical areas in Baltimore. So that is a quick thematic map for homicides. Now let's do a quick thematic map for racial diversity, and we're going to use race div 22. Of course, that is not the right variable. So again, race div, RAC div, not race, RAC div 22. And so now there's the racial diversity index. The higher the index, the more diverse the neighborhood. So you have some neighborhoods that are not very diverse, and you have some that are very diverse. By the way, this little square there in the center, whoever can tell me what that little square is gets a special prize. So, okay, so let's keep doing our QTMs. Percent lead 22. No. EBLL 19. EBLL 19. So what I was talking to you earlier is that the percent level lead only is in certain CSAs. The other ones have 0, and there's some that did not do any kind of testing. If you dive deeper into why they didn't do any kind of testing, you'll see that there's a very few actual. They're very old community statistical areas. So a lot of people there that are not the age that would be tested. And so the data gets suppressed. They don't release the data. And then let's look at income. And that one I do know it's MHII, MHHI. And I believe it is 19. But we can look and see if there's something newer. Yeah, no, it is. Yeah, no, MHI 2022. All right. So that is the medium household income. You have some places with very high income at the median. So remember, the median is not as subject to extremes as the average, the mean. So very wealthy neighborhoods versus very poor neighborhoods in other places. And then finally, the infant mortality. So it's telling me to use that, but I know better than to trust the Copilot right now. So mort1 underscore 18. So mort1 underscore 18. And that is the infant mortality. So some areas with very high infant mortality compared to other areas. Okay. So one of the things here that we need to understand is all of these variables have different distributions, different scales. Gun homicides is number of gun homicides per 1,000. Medium household income is money, right? It can go from 0 to infinity. More infant mortality rate is a rate, a percentage. Lead level, elevated lead level is also a percentage. So because they're on different scales, we need to standardize all of them. And then after we standardize them, we add them together. We add those z-scores together and create the index from the addition of those z-scores. Why do we standardize? It's to put them all on the same scale. When we put them on the z scale, we standardize them and make them normal, as it were. The formula for this is to take so gun homicides, for example. We take the average gun homicide rate for all the variables, all the CSAs, and then we go by CSA and we take the number for that CSA, subtract the average, and then divide it by the standard error of the whole sample. R will do this for us very quickly. It can take some time to do it in Excel. It can take a lot more time to do it by hand. I've done it by hand just for practice, and thankfully come up with the same results. So I'm going to show you how we do this in R. So let's get back to R, and let's do some more coding here. Yeah, let's do a quick correlation plot. So I'm going to cheat, and I'm going to remove the geometry column from all but the city map. So what am I doing with this? So the reason why I'm removing the geometry is that I'm removing all the information to do with the location of those CSAs. And the reason I'm doing this is to be able to analyze the data a little bit more cleanly. If you analyze the data spatially, that one variable, where the polygons were, can get in the way, and so don't really want to do that. So the way that I do it is, so for the racial data frame, which is right here, you'll see that the geometry is right here, and I want to get rid of it. So what I do is that I go and say st underscore drop underscore geometry. So that will drop the geometry. And what I'm left with is racial underscore dg. So it's the same data, but I don't have the geometry in there anymore. And that makes it easier to process. So we'll do it with all of them. And the code is right here, racial. And then we call it a pipe. So Control Shift M will write the pipe for you, or you can write it out. The percentage sign, Shift 5 greater than Shift 5, and that's. So what R will do is that it'll take racial and then do this on it. And if I were to add another pipe over here, I could do another another command on the same data frame. So once that I have all of these, I'm going to choose the variables that I'm going to work with. So you saw that each data frame had all sorts of different variables on it, right? From the different years. But I'm going to use the ones from let's see, what did I do? 2022 for the racial index. Elevated blood levels 19, gun homicides 22, median household income 22, and mortality 18. So these are my selected variables. And when I, sorry, don't highlight a letter and then run it. Choose the line and then run it. So my selected variables are now over here on the right hand side, and let me show you what that looks like in the environment. Now the selected variables are 5, and they are the ones that I picked. So what I'm going to do is I'm going to run through each one of these and just pick those variables and get rid of all the other ones. So let's go back to the script, and we are going to cheat and go get, we're going to join all the data together and choose only the variables we want. And so for that, what I'm doing is I'm creating a new data frame or a new data set called combined data. I'm going to take racial without with the geometry dropped, and then using the pipe, I'm going to then left joins percent lead by CSA 2010, homicides by CSA 2010, income, infant, and then from that whole big data set that comes out, I'm going to select the name of the community statistical areas and only the selected variables. So I can highlight it and hit Command Enter or Command Return, or I can just click Run. So combined data has now been created for me, and let me show you what that looks like. Combined data, it is the CSAs on the left, and then only the variables that I wanted are in there. Only the 5 are in there. Okay. So now I'm going to create histograms of all those, just so you can see what I meant earlier about different scales. So to create a histogram, I'm going to take combined data, which is the data frame that I'm working with. I'm gonna put it all together by variable and value, and make it into a different structure that goes by. You'll see the different structure. What I mean when I show you what it looks like. And then I'm going to make a plot, and that plot is going to be by the value of the variables. And I'm going to make a histogram of 20 bins with the fill sky blue, and the color of the border is going to be black. And then I'm going to have this facet wrap where I'm gonna put all the different histograms on there, and then I'm going to give them all titles, and I'm going to choose a theme. And so what you'll see when I run this is the different data are now here in my plots. So they are all sky blue, and they have the black outlines to them, and you can see they're different. They're different distributions, right? More infant mortality, racial diversity, gun homicides. So you have some CSAs with high numbers of gun homicides. You have some with none, or very little. Medium household income. You have some that have a lot of income, and you have some. You have a lot that have low income, and you have very few that have high income. The lead level, a lot of them have zeros, as you can see here, and then you have the ones that are elevated, and then you have the ones that are missing, but they're not showing. Mortality, same thing. You have a nice kind of distribution, not too nice, but you have a distribution there of those mortality variables. So this is just to visualize what you're dealing with. And now I'm going to choose which variables are lower, are better when they're lower. So what do I mean by that? When I'm going to standardize the data, some variables are better when they're higher, medium income, and racial diversity, right? It's better to have more diverse of a place when it comes to needs. Probably because it is more tended to. If the place has less racial diversity in Baltimore, which is a majority minority community, mostly African American, low diversity means that the neighborhood is likely to be more black or more white, and so that changes things of the needs. But when it comes to being more black, we know historically neighborhoods that are more black tend to be left out. They tend to be not taken care of. They tend to be not included in decisions and within their own city, which sounds crazy. but that's what that is. And so I'm saying that the lower is better when you have lower lead levels, lower homicide, and lower infant mortality. So that will figure into the calculation in a little bit, as you'll see. Okay, so I'm going to show you this function. This is something that I created myself. That's the neat thing about R, that if you don't have a piece of software to do something for you, you can write it yourself and get it done. So this is the function that I wrote. If you've seen some of my blog posts in the past, you'll see this function in there, or different iterations of it as I've been working through it. So I'm going to calculate an index. That's the name of the function. It's going to take the data that I give it and the variables from lower is better up here, um, and it's going to take out first. It's going to take out all the columns that are characters. So if it's numeric, it's going to leave it in. If it's character, it's going to take it out. Then it's going to take all the numeric columns, and we're going to be working with those numeric columns. What are we going to do with those numeric columns? We're going to replace all the NA values, or the missing values, with the average of the present values. This is a method of imputation. So some of those NAs in there, especially with the lead level, they break everything because you don't know what's going on. And so I'm just going to take the average of the present values and replace those, under the assumption that all things being equal, the those missing CSAs must have at least a mean or an average of the value that is missing. It's a big what if, right? It could be zero, or it could be the maximum. I can choose the minimum or the maximum. But I choose the mean. I can also choose the median if that is what works. But for this, for the purposes of this, I'm using the mean. So what it is saying is create a variable that across everything, if it is NA, if it is missing, it'll turn it into the mean, and remove all the NAs when you're calculating the mean. So don't take the NAs into consideration, or the missings into consideration when you're making the mean. And then we're going to standardize the numeric columns. Like I said, we use the scale. You use the scale, and I'm going to show you real quick the results here in the help section. And so scaling, it is what it is doing is calculating the z-score. It's centering on the z-score. So you might want to look at this. This is the formula, like I said before, the difference between the value and the mean divided by the standard error. If you're using a correction or not, it's a little bit of more advanced biostats, but just know that what it is doing is standardizing everything on the z-scale. That is what scale is doing. So and then it's going to reverse the sign of lower is better variables. Remember, if lower is better, then I need to multiply times -1 so that I can make those higher and better, right? So I'm not adding up z-scores that are on different in different directions. So for example, more lead levels, more percentage of kids with high lead levels is bad. So I don't want to add that to the median household income, when median household income is good, and the higher it is. So I want to flip it. I want to flip that lead level so that lower is good, and now they both match up together. Then I'm going to add all the numeric columns into the value called index. This is where we're going to map. And then we're going to put it together into a data frame, like the data that is on the right hand side here on the screen. Right screen only. Right here on the right is all these data frames. And then I'm going to take a little drink of water because I can hear my voice going. And then I'm going to sort the data frame by index. So the lower and higher, and then get back the results. Why do I sort it by the index? Just to make it a little bit cleaner, a little bit better. So I'm going to create this calculate index here. And now you will see it on the right hand side in the environment, that it is a function, and the function requires data, and it requires the lower is better variables, right? And so I'm going to do this now in the script. So calculate index, which I just created. My data is going to be combined data. Remember that I combined all the data from all the different data frames without the data, without the spatial data. Lower is better variables. I remember I made them here. I created lower is better variables. So I'm going to run, and then I'm going to print standardized data just so I can take a look at it. And when I hit print on that, it appears in the console. So each CSA now has the value, the z-score value for racial division. I'm sorry, racial diversity, elevated blood lead levels, gun homicides, mean household income or medium household income, mortality, and then the index. So what does that mean? The higher the index, okay, the higher the index, the more needs that place is gonna have. That is simply, very simply, a very quick way of doing this. It is a very quick way of finding out which of your neighborhoods have the higher needs. So if you think about it, um, you have all these variables for the different neighborhoods, and you're finding a way to squish them together into one variable. And when you squish them together, you have to make sure that they're all on the same scale. And to put them all on the same scale, you standardize all of them with the z-score. There are other indices out there that are used, and they're valid, and they're great. They use different formulas. This one is the most simple one. It's a very quick, very easy that you can do, but you need to take different things into account, right? And we'll talk about those as we finish mapping all of this. So let's go back to the script. Now I'm going to join the standardized data with the city map to get the geometry back, so I can make it a map. So I'm going to call it map data. CSA 2010. Okay, city map. What does city map have? It doesn't have CSA 2010. It has community. So I need to join them by CSA 2010 or community. So I can either go back here at the top when I'm bringing the city map in and rename community to CSA 2010, or here in the joining, when I'm doing the join, sorry, or here when I'm doing the join, I can say by C, and then on the city data on community equals CSA 2010. That didn't work. All right. How did I do this? Is it the other way around? CSA 2010. Yes, that. So CSA 2010 in my standardized data, community in my city map, and that's how I join it to make map data. So let me show you now in the environment that I have now map data. And when I click on map data, it opens it in the script, and this is my map data. So this is what I showed you. It's the different standardized z-scores for the different variables, the index, and then now we have the geometry. So now we know what we're going to be mapping. Let me hit save there just in case. Always save, always save, always save. Okay, so we're going to be creating the map. So again, I'm going back to my previously written stuff. So histograms for each variable. With the combined data. So just like we did before, when we used the histograms for the variables, now we're doing it for the variables one more time to show you something interesting. So you've seen this one, as this is the same that I made for you before. But now let's go back and do a correlation matrix to see which variables are highly correlated. So correlation matrix is core, combined data, pipe select CSA, so do not select TSA. That's why we have the negative there. Use complete observations, and then print the correlation matrix. So the correlation matrix appears in your console, and from that we are able to see what variables are correlated with what other variables. Remember, a correlation of one is perfect correlation. So obviously racial diversity is going to correlate perfectly with itself. Um, you want values that are as far away from one as possible. That means that they're not correlated, and so they're not informing each other. You're not getting the same information from both those variables. If they're highly correlated, there's no point in putting them in the index together because you're getting the same information, right? So we're going to create a correlation plot. And so GG core plot, correlation matrix, the order in which you want the variables, and then your correlation labels. And so what that looks like is in the plots is this. So we're taking the numbers that we saw in the console and we're just making them visual. So you'll see that gun homicides and infant mortality are very are somewhat correlated highly at 0.52. They're the highest correlated positively. So as one goes up, the other one goes up. Medium household income and gun homicides are the highest correlated negatively. As household income goes up, gun homicides go down. So that is how this is what you're looking in the correlation matrix. So this gives you some clues as to what's going on, right? So let's do some data analysis, further data analysis, by going back to our script, and we're going to do a scatter plot of household income versus homicide with a regression line to show you that correlation that you just saw. To combine data, I'm going to make a plot with median household income in the x-axis, gun homicides in the y-axis. The points, the dots on the scatter plot, I want them to be sky blue. I'm gonna give them all these labels, and then I'm gonna use the classic theme for that scatter plot, and then I'm gonna add a line, a smoothing line, a regression line with no standard errors. And I run that, and I go over to my plots, and you'll see here that again, the lower the household income, the higher the gun-related homicides per 1,000. And that this is a very quite strong, actually, correlation, negative correlation. As one goes up, the other one goes down. And yeah, the wealthy neighborhoods don't have as many. In fact, you have 4 neighborhoods here that are very, very wealthy, and they have a gun-related homicide rate of 0. So they don't have gun homicides in those, which is very interesting. Now let's look at the histogram of the scatter plot of gun homicides and infant mortality. It's kind of the same correlation, but it's positive. As one goes up, the other one goes down. As one goes up, the other one goes up as well. And you see that the higher a CSA has a gun-related homicide, the higher its infant mortality. And you have this one up here on the upper right that has one of the highest gun-related homicide rates and one of the highest infant mortality rates. So this neighborhood, the CSA is in trouble, right? And so you might want to look at your data and find out which one it is, and take a look at it much in detail if preventing death is your mission for Baltimore City. Okay, let's go back to the script, and now we're going to do a histogram of the standardized variables. So the standardized data, which was what we used the function for, we're also going to do a histogram of those standardized variables. So this should be a little bit different, but not too different from the plots earlier. So histogram of the standardized variables are here. And again, the z-score is 0. If your z-score is 0, is because your CSA's variable is the same as the average. So average minus the average of your variable. So for example, gun homicides. If your gun homicide rate is the same as the average rate for all the CSAs, then it's going to zero out the z-score. If it's way high than the average, then your z-score is going to be high. If it's low, it's going to be negative. So you have most of the neighborhoods here for elevated blood levels are around the mean for the all of them, and then you have the ones that are very high values for lead levels. But remember, because we flipped it, now we turned it into negative. So they're the ones that are going to be having more needs. The lower the value, remember, the lower the value, the worse it is. So but the lead level was the higher the worse. We flipped it, and now it's the lower the worse. So these are your standardized data. If you remember, in your standardized data for gun homicides and infant mortality, it looks the same because again, you're just transforming the numbers. You're not making up new numbers. You're not making up new data. So it is it is what it is. So I just saw your message. Hey, awesome session, but the quality is kind of low. Voice is clear but slightly low. Well, it is one of those things that I'm gonna have to be working on as we go. Just the gain, I guess, on the microphone, etc. So we'll, first time around, we'll get it done for the next time. But I'm recording this in high definition, so you might want to watch the recording. It'll show better, and that is kind of why I am showing these. So just so you see it, let me see what is going on here. One second. Wanting the stream current bitrate is lower than the. Yeah, I got that message. And the recommended use a stream bitrate of 2350. Okay. Okay, so the stream status is good. It's going up and down depending on the network. I apologize for that. I'll keep that in mind for the next time. Okay, so let's just finish this off, and then we'll address all these issues, and we'll get a better one next time around. Okay, so we've done the scatter plots. We've done everything. Now we're gonna make some maps. So I'm gonna switch over to this file just to stop copying and pasting and moving it over. But tmap is gonna be set to plot. So it is when I set the tmap to plot, it's all going to be plotting in the plots on the lower right, as you can see down in the lower right. So first, my map of racial diversity index. I'm going to be going through each one of those variables, and I'm going to make them pretty. Remember, the first time I showed you, they didn't look too pretty, but hopefully now they're a little bit prettier. So I'm going to take racial. I'm going to the racial data frame, I'm going to TM shape. So I'm going to make the shape out of that. I'm going to fill it with the race div, the race div 22 variable. I'm going to style it with quantiles, so fifths. I'm going to make it blues, but I'm going to put the negative in front of it so that bluer is worse. And I'm gonna post all this. I'm gonna post the script for you guys later on, so just bear with me. Title is racial diversity index. The legend is going to be with the percentage format, so there's the code for that. The borders, the scale bar, and the layout. And let me just run this so you see what I mean in the plots. So this is the racial diversity index, and I didn't change to 2022. So let's do that. So there it is, 2022. And so you have some places that have a low racial diversity index, and you have some that are high racial diversity index. So remember, higher is better in this case. The city is not very big. It's about 12 kilometers from east to west. So you're gonna give your audience a sense of perspective of size with the kilometers. Let's see. Let's see what else. We added the percentages to the plot, and you saw that in the script here under legend format. where it's a quick function that what it does is that it takes the number, rounds it, and then just puts a percentage sign behind it. A background color of light gray, you can change that as you want. There's a lot of, if you look up color brewer online, you can see the different colors that you can use. I put the legend outside the map and I remove the frame, and it's all to make it look nice and pretty. So let's do this again. And the neat thing about coding, guys, is that you don't have to go and point and click and do it all over again. You just copy this and you paste it, and then you just change your variables. You see that it's gonna be the same, kind of the same map, but in this case for elevated blood lead levels. And I went a step further here and I added the values because I wanted to see the ones that were high. And so yes, 6% of children in this CSA here on the east side, and 6% of children over here, and 1.7% of children here had elevated blood lead levels. Everywhere else it was zero. So that is pretty interesting. Not too long ago, Baltimore City had a big issue with elevated blood lead levels in a lot of the neighborhoods, but that seems to the lawsuits that came from that seems to have fixed that issue. So going back to the script of how I made this map, percent lead, and then I used elevated blood levels. I rounded the values up because I wanted to use those for the text. And you'll see here text, that's what I used. And that's the size of the font that I used. You can play with different size fonts to see what fits better. Same as I did with the other legend, I made sure that the legend itself had the percentage sign on it. Nice descriptive titles, and the legend is outside, and the scale bar is in there as well. You can also, if you don't know, you can also add um, you can also add a North Star compass, and what that looks like is a little bit. Let me see. I want it in the left bottom. And now when you look at the plot, when you look at the plot, now I have a compass, so you can tell people which way is north, in case they don't know. This is handy when the map that you're making is not oriented north. Usually all maps are oriented north, but once in a while you'll have some that are not, and so you want to put the North Star there. Okay, so I'm going to run the other code so you can see it, but like I said, I will share all the code at the end. This is the gun-related homicides per 1,000 residents. So you see that some neighborhoods have very high gun-related homicides. And if you notice, I try to stay consistent with the colors. Darker is worse. Darker is worse. Darker is worse. Medium household income. Darker is worse, right? Darker is the lower household income. Lighter is the higher household income. And I hope that you can start seeing a pattern now, right? You have a butterfly shape around the center of the city, and you have an L shape right down the middle of the city, and the butterfly tends to have the worst outcomes and the L tends to have the better outcomes. And that is that article that I was mentioning. It's in the description of the video on the black butterfly and the white L. And then infant mortality rate, again, darker is worse. And so you see, again, that's what is being seen here. You see that L there. And then finally, the map of the combined index. So let me go back to the script. And this is a combined index. So I'm taking map data. I'm using the shapefile from that map data. I'm going to use index. The middle is 0. Remember, if it's 0, it's right down the middle of the range. Quantile, so a fifths of the variables. So every 10 CSAs or so. The palette is going to go from red to yellow to blue. And it is, again, remember, darker is worse. For any missing values, I'm going to have a black color, but I don't have any missing values. I'm just putting this in here just out of habit. In case I do see any black in the map, I can go investigate why am I missing those variables. The title, Unmet Health Needs Index. The legend format, I'm rounding to two digits, significant digits. It's going to have borders and a scale bar, and then the title, the legend is going to be outside, the title size is going to be 1, and there's not going to be no frame on there. So I do this, and now we go see our final map. So here is our final map. You see, we have squished together. Um, we have squished together all the variables, right? All the variables, different scales. We change them to the same scale, and then we squish them together into the index. And this is the index. So the darker is worse. The lower the index value, the more needs there are in those community statistical areas. The higher, the less needs. Again, the black butterfly shows up here, right? The butterfly and the L again. You see them very clearly, and this is something that comes up year after year after year after year because again of segregation, the systemic racism, and everything that happened in Baltimore in the last 150 or 200 years. One of the neat things that you can do with R too is use a live map. So let me go back to the script real quick to show you what a live map looks like. So you go to tmap mode. Remember previously tmap mode was set to plot and now it's going to be set to view. And now I'm going to view, hold on, I need to do something real quick. Okay, let me show you the plot. One second. Okay. So now I'm going to run that code and it should appear here in a second. And now it's appearing over a live map. Well, not live, but an actual map like you see on Google Maps. And what I'm going to do to better visualize it so you can see it a little bit better, I'm going to use right screen only and I'm going to make it, I'm going to zoom it. And now I can see the areas around it, and you can make it even, you can change your base map and you can actually see what areas there are. And remember that square that I told you that didn't have any values to it? It's because that is the detention facility in Baltimore City. And so it doesn't count as a neighborhood. It's the Maryland Metropolitan Transition Center and Detention Facility. So it's the jail. So that's why it doesn't have any colors to it or any values to it. So this is Baltimore. These are the different based on the health needs. Soundtown Winchester is where the riots in 2015 happened. So as you can see, a place with a lot of needs, not just health, but in other domains as well. Greater Rosemont, Southwest Baltimore, Cherry Hill, Old Town Middle East. Everything around Patterson Park has been gentrified, by the way, and so you see it dropping. If I were to have done this a few years ago, some of the red would have been here too. The Inner Harbor, areas where a lot of tourists go to, is they have lower needs, and so that is a neat thing that you can also do with our studio is that you can create a map, and you can then copy and paste this or take a screenshot and send it over to your boss. So I want to point out a little neighborhood that is near and dear to my heart, not because I was born there or because of anything else other than the need in that neighborhood. And it is called the Six Blocks right here. So this area here behind the Catholic High School of Baltimore, very, very high number of homicides, shootings, robberies, overdoses, low income, substance use, substance abuse, etc., etc., etc. in this neighborhood. And it is very small, but it is highly concentrated, place of great, great need. The household there, the homes are pretty old. And there's just a lot of need in that neighborhood. And some people call it the 6x6. Some people call it the 4x4 because you have the four main streets and then the other four this way. But people call it the 6x6 because they look at it on a map. But the 4x4, and so it is right next to this a church and a Catholic school, and this the cemetery here, the Hebrew cemetery, the Baltimore cemetery. But it has a lot of needs, and that is one of the places that I have studied in my epidemiology of gun-related homicides in Baltimore. So with that, ladies and gentlemen, I want to thank you all for sticking around till the end of this. We went a little bit over the hour, and I apologize for that. But also, I feel that I managed to get in everything that I wanted to tell you and everything that I wanted to show you. So this is all the code that I'm gonna put at the I'm gonna put in the description when I finish later tonight. I'm also gonna have this on the Substack. Remember, go to phnightschool.substack.com/March code along to to get a special promotion where you can access all the members only stuff for 30 days. After that, if you choose to stick around, $5 a month buys me a coffee. If you don't want to stick around, that's fine. If you want to go free, that's fine. This is a labor of love. This is something that I'm doing again because I want to improve my skills in speaking and teaching these concepts. And also, we're at a time where we need more public health and we need more to understand more about the evidence and the science behind all of these things. So thank you so much for your attention. Thank you for being here tonight. Again, comments, concerns, constructive criticism, I am all for it. Let me know. Let me know what you think, and I will set another code along for next month. And then I want to remind everybody that in May we begin with the Biostats Night School. So right now it's epidemiology, and then that ends in April, and then we do in May we're gonna do biostatistics. So for that we're gonna use a lot of R, a lot of try to understand biostatistics in an intuitive way and with a lot of real life examples, and we'll use the R code as well. So with that, thank you so much. I really appreciate it. Have a great night. Take care of yourselves and be good.